Well, hello, Frappy Freaks. We are going to finish our lesson from yesterday. So we were talking about how to find the z critical value using the normal curve. So we talked about if we want an 80% confidence interval, we're looking for that 80% section in the middle of our normal curve. So there's 10% on each of the tails. And we talked about how to get the z-score or the z-score related to each one of those stop points. So I just wanted to take a second. We kind of did this quickly, so I wanted to show, we talked about the area of 90%, that's the 10% plus the 80 in the middle, that gets up to this marker right here. So we just talked about how to get it. I just want to do a quick demonstration of that. So we're going to pop over to a different window. Don't mind this for a second while we pop over to Google Classroom over here. There we go. And if we take a look at our z table and look at 90%, it will pop up here. Here we go. 90%, we're looking for 0.9. All right, somewhere in here. Looks like we have, right about here, we have 0.8997 and we have 0.9015. It looks like this 8997 is a little bit closer, so that is 1.2. And then if I follow this up to the top, 8, which matches what we already said in our notes. So again, that positive, that's where that positive 1.28 came from. But there is an additional way that you could do this. You could use your calculator. So I want us to take a look at that as well. So the way you would use your calculator to do this, you would still draw your normal curve, but you would type in, or not type in, press the buttons menu, then statistics, then distributions, and then under distributions we are looking for inverse normal. So inverse normal is our way of saying, hey, we're starting with an area and we want to go back and find the z-score. So inverse normal is how we go backwards to find the z-score instead of starting with the z-score. All right, so I'm going to show that. I'm going to close this out one more time and we're going to pop over to calculator. Here we go, calculator. So I'm going to go to calculate and I'm going to hit menu, statistics, distributions, and I'm looking for inverse normal. So this asks for what area are we looking for. So the first one we did was 10%. That was the left part of our tail, so 0.10. And then on a standard normal curve, we would have 0 for our mean and 1 for our standard deviation. And then I just hit OK, and notice it gives us that negative 1.28 that we already had. And then to do the second z-score, z-critical value, I would go ahead again and press menu, statistics, distributions, and then I would find inverse normal. Sorry, went right past it. There we go. Whoops, hit something crazy. Try that one more time. Menu, statistics, distributions, inverse normal. There we go. And this time I would do 0.9. Again, even though the area that I'm actually looking for is the 80% in the middle, I have to do it in reference from like the left of the graph. Anyways, and again, so mean is going to be 0, standard deviation 1, and I hit OK, and there we get that positive value. So if we are truly going for that center piece of our normal curve, the z-scores on the right and the left will be the same, just a positive and a negative version. All right, so let's pop back to this. So we can just jot down kind of what we just saw. So again, using that command of inverse normal, there we go. And then what we type into the calculator is 0.1. then what they already had for us was 0 and 1. And just to make sure we're clear on what those numbers mean, this one is our area under the curve. This one was the mean, and the 1 was the standard deviation. And then we found this equals 1.28, and then we did it one more time, inverse normal, and this time we did 0.9, and then 0 and 1. And again, the 0.9 is the area, the 0 is the mean, and the 1 is the standard deviation. So it is really important to still draw that normal curve so we're clear and we can figure out what we are actually looking for. Okay, so let me just get this corrected and we'll move on. And this one gave us, oh, I did that backwards. I apologize. This one's negative 1.28 and this one is 1.28 because the first one is on the left side of the mean and the second one is on the right side of the mean. Much better. Okay. Moving forward, so our confidence interval for p hat, we have when our conditions are met. This is the format for our confidence interval. We have that first piece right here, the p hat, that is our estimator. And then we have to the right of the plus or minus sign, this whole section. Now this is that margin of error. We have our z critical value. And then we have the square root piece, of course, is our standard error, which we know is basically standard deviation. All right, so the z critical value for at the bottom there says where z asterisk is the critical value for the normal curve with a c% of its area between negative z and positive z. Let's go forward. All right, so example 4. We are going to calculate and interpret a 90% confidence interval for P for Mrs. Ballard's class back from example 1. So back in example 1, and this is important, we do need what was our P hat. So our P hat back in example 1 was the 13 purple chips out of 102 that were in our sample, which we had the decimal approximation of 0.1275. Then to build our confidence interval, we already checked the conditions for this situation back in a previous example, so we don't have to check conditions. So we are going to start building our interval. It's going to be p hat equals, plus or minus. So we have the point estimator, which is our proportion, plus or minus the z critical value times the square root, which this part right here is our standard error or standard deviation of p hat 1 minus p hat all over n. Fantastic. So the p hat we know, the n we know, the only thing we don't know is the z critical value. So I'm going to go back to drawing a normal curve, just like we did a moment ago. There's my normal curve. Here's my mean. And I'm looking for a 90% confidence interval, which means between these two z-scores, I want to see 90% of my data. So with that 90%, what percentage is left on the outside or left over? I have 10% total, but I have to split it between my sides. So when I split that between the two sides, I get 5% for each of the sides, which means the area for each side would be 0.05. And this one would also be that same area, 0.05. And then from there, we would need to decide what area we are going to look up on our z table. So this first one here for this first z-score is going to come from looking up that area of 0.05. So if we look that up, and this one I will have you guys do on your own, or just trust me, we are going to get negative 1.645. So actually maybe I will have us look it up so you can see how I got that value. Let's take a look. Negative 1.645, we are looking up, we're looking up an area of 0.05. So let's pop over to here. So we're looking up an area, so in the middle, 0.05. So 0.5 is what I'm looking for. 0.5. Looks like right here I have 0.0505 and 0.0495. These are both 5 away from 0.05. So one's a little bit more and one's a little bit less. So you can see why I was picking the midway point here. So negative 1.6, and then if I scroll up to see what numbers I'm between 4 and 5. So negative 1.64, and then the halfway makes it an additional 5. If you're not sure there, just pick one, do 1.64 or 1.65, and you should be fine. Okay, let's pop back to our notes. All right, and so we are going to, so we have that one, and we could go and look up this one. Just be warned on this second one. Let me turn this back into our presentation. On the second, if you look up the second z-score, that you must add the two areas here. So I would be looking up for an area of 0.95 in order to actually give me the area of the 0.05 on the right. So to do that, again, I would look up an area of 0.95 to get this z-score here, and I should end up with a matching 1.645. And since they are matching, you really only need to look up the 1, in case you were wondering. You really only need the 1. All right, so into my confidence interval, my p-hat was 0.1275. I have my z-critical score, which is plus or minus the 1.645. And then I have my square roots, my p-hat 0.1275 times 1 minus 0.1275. And then our n, our total there was 102 chips in our sample. So we would put that whole loveliness into the calculator, and we're going to pause here for a second for you guys to be able to try this out on your calculator. So go ahead and try it out. All right, coming back. Our interval that I did when I put this in the calculator was 0.0732 for the lower bound, and the upper one I have 0.1818. So that's how we would write the interval actually, but then in terms of our interpretation, which we'll do in a second, we'll put it into words, but this is how we would write it as an interval, the start and the stop. So here goes with our interpretation. We are 90% confident, because that was our confidence level, that the interval from 0.0732 to 0.1818 captures the true you can say population proportion, or we can just say proportion, because it is implied if we say the word true that we are talking about the population, the true proportion And here's where we have to put in our context, the true proportion of what? In this case, it was of purple chips in the bucket. And there you go. You have done your first confidence interval. Congratulations. That, oh no, we do have one more. I apologize. Nope, it's in the next lesson. Okay, so that does conclude that lesson. Let's take a look at that last success criteria that we didn't quite finish yesterday. I can construct and interpret a confidence interval. You just officially did that. So go ahead and check that off if you've got it, or you can circle it if you're not quite sure. Make sure you guys take a minute and write a quick summary or reflection about your learning from this lesson in your notes, and you should have a homework assignment to get started on.